In this video, we're going to work through number 3, the Ferris wheel problem on the worksheet, story problems worksheet, and then you'll go back and do number 1 and number 2 as part of your homework. So we'll work through this as a way of figuring out what we're going to be expected to do. So in this Ferris wheel problem, as we ride the Ferris wheel, and you can see it here on the right there, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is on the position shown. So here's where we are when the Ferris wheel starts going. It says that let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes 3 seconds to reach the top, and the top of that Ferris wheel is 43 feet above the ground, and that the Ferris wheel makes a revolution every 8 seconds. So we're going to get one full spin around there every 8 seconds, and that the diameter of the wheel is 40 feet. So that diameter is going to be 40. Okay, so let's see if we can figure this out a little bit. We know that the tallest we're ever going to be is 43. So the tallest our graph is going to be here is going to be 43 feet. Since our diameter is 40 feet, that means that the lowest we're ever going to be is going to be 3 feet. So that's going to be the lower boundary of our graph. It's going to be sinusoidal, so we're thinking of this as being a sine or a cosine. We are told that in 3 seconds it's going to reach the top. So at 3 seconds down here, we're going to be at the top of our graph, which is going to be right up there. I think we can see the midline, so 43 minus 3 is 40. That's going to be from the top to the bottom. Half of that is 20. So if we go up the 20, that's going to put the midline of our graph at 23. So we're going to be at the high point at after 3 seconds rather. Since it makes a full revolution every 8 seconds, that means if we add 8 seconds to the 3, we're going to be back up to the top. So I'm going to say maybe right there is going to be 11, and then we'll be back up at the top again. That means halfway in between there, we're going to be at the bottom. So if it's 8 seconds, half of that would be 4 seconds. 4 seconds added to the 3 will be at 7 seconds. We're going to be at the bottom. And then in another 8 seconds, so that would be 8 added to the 11, would be in 19 seconds. We're going to be back up to the top again. That means adding 8 seconds to the 7, in 15 seconds we'll be back to a low point. Okay, and it says, sketch the graph of the sinusoidal. I'm going to back it up just a little so I can kind of get a smooth curve and get an idea of where it's going to cross the y-axis. So our distance here is 4. So if I go 4 more to the left, that would be at a -1. And that's going to be a low point, even though we're not going to be, we're not going backwards in time. So if I try to connect these with a curve, something that looks like a sine or a cosine curve, I'm going to try to get something that looks sort of like that. So there's part A. There is our sinusoidal graph. Okay, that's us going on the Ferris wheel. Kind of makes me a little sick to my stomach just graphing it. Okay, part B, what is the lowest we're going to go as the Ferris wheel turns? And that is going to be 3 feet. And why is this number greater than 0? I think that's a good thing. If it wasn't, it would be a very rough ride, right? So we don't want to actually hit the ground. That's why that's got to be positive. Be not a very fun ride if it was 0 or negative. Now we're going to try to come up with an equation. So let's come back here and think a little bit. We have many choices, like we've seen before. And shall we just, I'm going to just choose 3 to be the starting point. So at 3, since we're at a high point, that's going to be a positive cosine. And it's going to be a t minus 3, because that's our translation. We can see that our amplitude is going to be 20. And we said it was a positive cosine. We can see that it's been translated up 23 because of the midline. And now the hard part is always figuring out what our b is. Remember, we normally say that the b is going to be our natural period divided by the actual period. And since our actual period, the distance from a high point to a high point is 8 seconds, then that means that our b is going to be pi over 4. So this is our equation. This is one equation, it's not the only one, for our sinusoidal. So that's our answer to part C. Then we want to predict our height above the ground when t is equal to 6. So for D part I, that means we're going to plug in 6 for the t. So we're going to get our height is going to be 20 cosine of pi over 4 times, that's going to be 6 minus 3 plus 23. So we are going to have to go to our calculator for this one. So times 3 plus 23, so that's going to be y equals 20 cosine of, that's going to be 3 pi over 4 plus 23. And we could actually probably do that one. We know that the cosine of pi over 4 is square root of 2 over 2, and that in quadrant 2, our reference angle will be pi over 4, but the cosine will be negative. So if we wanted the exact value, that would be 20 times negative square root of 2 over 2 plus 23. We could cancel that, and that would become a 10. And we could get a negative 10 square root of 2 plus 23. I think at some point, and this is probably that point, we're going to have to put this into our calculator. And if you throw that into your calculator, and you actually could have even done that here, then I believe we're going to get 8.858, and that's going to be feet. And so our height after 6 seconds is going to be 8.858 feet above the ground. And then we want to do it for 4 1/3. So I'm going to come down here where I have some space. So now t is equal to 4 1/3. That is the same thing as 13/3, I believe. So we're doing 4 1/3, yep. So we're going to get y, or the height, is 20 cosine of pi over 4 times, and if we subtract 3, which is 9/3, that's going to be 4/3, and then a plus 23. So this is actually going to be, because we can cancel those 4s, we get a really nice value. Cosine of pi over 3 we know, and cosine of pi over 3 is actually 1/2. And so that means we're going to get 10 plus 23. We're going to be 33 feet above the ground at t equals 4 1/3. I think that's the end of this. Yep. All right. Very good. Is that all we had? Let me check. Yep, that's it.